Keep this equation in mind. Do you guys want to write this on a piece of paper and keep it with you and see if we come up with the same equation? So let's do scattering. Compton scattering formula. And you are going to need a lot of information from intro 1. So we will begin. What is a scattering experiment? Imagine this electron is sitting here by itself, minding its own business, not bothering anybody, but Compton comes along and says, I am going to hit you, electron, by a photon of a certain frequency, X-ray, certain frequency, let's call that frequency F. So this photon has a frequency F. That means it has energy equal, there we go. And could I write its momentum as HF over C? Momentum is m times v. Almost moving with the speed of light. Its energy will be photon energy. What is the rest mass energy of a photon? 0. So isn't its energy equal? Remember Einstein's equation? E equals m squared c squared plus p squared c squared. Do you remember doing that? Okay. So if its rest mass energy is 0, sorry, this should be a squared. So shouldn't this be equal to PC? So if I plug this value, HF here, will P equal HF over C? Oh, this is, by the way, it shouldn't be part of the thing, but you see where that is coming from? May I erase that or leave it? Okay, I'll put it in a box. Actually, let's change the color of it so it doesn't seem like it's more important. I'm trying to make it as insignificant as possible. That's better, right? Okay. What will happen to this then? This photon, they were observing that it didn't have the same color as it did before. So blue turned into like a purple. Like that's, I'm just making stuff up now. I don't know if blue turned into a purple, but just to change the color. And the electron actually recoiled. So classical physics says I can do that, and I can call this phi, and I can call this theta. Is that true? And for my blue photon, can I write its energy as HF prime? Remember, the frequency will be different. And may I also write its momentum as HF prime over C, following the same logic? And for the electron, its initial energy is mc squared, because it's not moving, so it can't have a momentum. And its initial momentum is 0, initial energy is mc squared. Once it starts to move, may I write its energy final as m squared c4 plus p squared c squared? And p equals p final. Can I just call it a p? It will have some momentum. Don't necessarily worry about what it is. It's going to be some relativistic momentum. I'm not concerned about the actual value right now. And this is a scattering experiment. We consider it an elastic collision. So what do we know about an elastic collision? I know for a fact that momentum and energy must be, what's the word? Conserved. Classically, that means delta P equals 0 and delta E equals 0. That's what I know from intro 1. Collision experiments absolutely know that momentum must be conserved and energy must be conserved. Elastic collision, yeah. So let's discuss both of these individually.